Okay, sir. Recording started.
Okay, thank you. Okay, so I welcome all the participants in the last day of our FDP, ATAL FDP, AI Revolution from Machine Learning to Generative AI. So today's first talk will be from Dr. Srinivasa Murthy. Sir, your topic, because as it is emergency, immediate. Okay.
Sir, it will be with respect to hands-on session with medical image processing as well as speech processing.
Okay.
Generative AI also a bit of.
Fine. You only explain. It is related to medical imaging and I think speech processing related things will be there. So I request Dr. Srinivasa Murthy to deliver the session.
Thank you so much, sir. I hope the audio is fine. Everything is fine, right? And the screen got shared.
Oh yes, it is sharing.
So, dear participants, I would like to know whether you wanted to explore a hands-on session with uh, medical image processing, that means breast cancer classification, or otherwise you want a theoretical session. So it will be completely your wish. Can I have one or two opinions so that I'll proceed accordingly? So hands-on with medical imaging, so you can do hands-on together. Is my voice getting big? So one second, let me get my headset. Is it fine?
Yeah. Can anyone tell me? Is it fine? Is it fine?
Some humming sound is there, background sound.
Okay. Echoing is coming, right?
Echoing.
Now?
Now it is, I think, proper.
Now it is fine, right?
Yes, perfectly fine.
Yes. Thank you so much.
No. Again, somewhat I think echoing.
Yeah, I'll turn off one sound completely. Now?
Yeah, now it is perfect.
Yeah, thank you so much, sir. Fine. Dear participants, may I know on what topic you have? That means, should I teach? So, should I go with the medical image processing hands-on session, or otherwise, should I go with speech processing hands-on with the theoretical background? So that's up to you. And a bit of Gen AI also will cover. So can I have some? medical imaging hands-on session, right?
Yes,
Yeah,
sir.
fine. Yeah, fine. So then, all of you, please, you can do along with me, because we shall do with one particular data set by taking the data. So along with that, how to use ChatGPT also I'll explain efficiently. So we have ChatGPT premium version. So, now, if you are capable of utilizing the ChatGPT, that means how fast you can write the code as well. All those things I'll explain today in today's session, if it is okay. So for this process, let me give a detailed analysis on the medical imaging. Yeah, so this is what I had taken as a topic. Let me explain for half an hour the theoretical session, then I'll go with the hands-on session. So, as I said, that medical informatics is the branch of science concerned with the use of computers and communication technology to acquire, store, analyze, communicate, and display medical information and knowledge. So till now, this definition taken by Warner et al. So which is published in Knowledge Engineering in Health Informatics in 1997. So this is the title of the paper. So to facilitate understanding and improve the accuracy, timeliness, and reliability of decision making. So these are the formal definitions. That's why I read completely. Fine. Clinical decision making. What is the necessity of um, uh, machine? In this case, I would like to explain clearly here. So, if I fine. So one thing is right information. See, suppose whenever we go to a doctor, previously my parents and grandparents used to tell that whenever we go to doctor, they will touch our hand, and they will touch some portion of the stomach, and they will tell the exact problem, what kind of problem uh, they had. So that is the right information they used to give. At the same time, right time. That means, suppose the particular person is having initial urinary tract infections. If you can identify initial urinary tract infections, it may not lead to the culture test, and it may not lead to the failure of kidney and all those things. So that means, at right time we have to give the information, at the same time in right format. So uh, that means the proper analysis information should be provided to the patients. So this is the aim. It can be done by the human beings as well as machines as well. So see, without nowadays, if you go to doctor, first of all, if you tell any small problem, suppose if you tell UTI problem, then what they will do, they will ask you to go for what is the test? There'll be urinary test analysis will be there. That is one thing. Then they will go for the culture test. They will go for the ultrasound scan. All these things they will do, and they will take a decision. So which is likewise, that means here, all at all stages the machine is involved. So that means whenever we are doing the ultrasonic, then there will be ultrasonic sensor. It will go inside and it will tell if there are stones and all those things in the kidney. Fine. So then the next case is ambiguous. So that is, what is the problem? Suppose if you go to one doctor, he will tell this is your problem and you take these kind of medicines. If you go to other doctor, he will tell this is the problem and you use these kind of medicines. So that means the ambiguity in the uh, issues, and incomplete information, and the poorly organized the process. So that means here we need proper decision making devices. And similarly, what is the other important aspect that requires machine involvement? Rising tide of information. One is making sound clinical decision requires, and second one is clinicians face a surplus of information. That means they won't get proper information to decide what kind of disease we have. And third one is rising tide of information. So whenever if you go for one CT scan, it will generate hundreds of pictures. Analyzing hundreds of pictures by human being is practically not feasible. Then in that case, we have to go for the machine involvement. So at the same time, there are 40,000 new biomedical articles are coming every month. Getting gist of those things is very, very important. Here we need some summarization systems are required. So and fine. So whether this AI has been started recently or is it available already? For this particular purpose, I would like to tell a small story. I used to study. I have studied it in WhatsApp 3 years back, but I used to recall the story whenever I used to give talk, because the story will give the importance of keeping the information secured, as well as the growth of medical AI at the present stage. See, one middle-aged person, he will go to the home at late night at 7:30. No one will be there at the home, and there is rain outside. So he wanted to eat something. Then what he will do is he will order a medium-sized spice pizza from the nearest Domino's shop. So he's a techie guy like me. Assume that he always use technology whenever he want to deliver, whenever he want to order something. So then what he has done is, hey Alexa, can you order a medium-sized spice pizza from the nearest Domino's and pay the money from my credit card? Then the Alexa will say that, sir, recently you are diagnosed with diabetes and your sugar levels are this much. So it may not be suggestible to order a medium-sized spice pizza at this time. Then this guy will get shocked. Okay, Alexa, can you order normal pizza? No spice with no. Can you order pizza with no spice? Then that person, that Alexa will say that, okay, sir, I'll order, but how you'll pay the money? Then Alexa will say, I'll pay from my credit card. So you have not paid the credit card bill from past 2 months, and your outstanding is so and so, and your card got blocked, and your credit score has been reduced because of this. So you cannot pay the money from card. Then the person will say that, uh, I'll pay through my debit card. So then Alexa starts saying that, sir, your money in the debit card is low. Whatever the money that you have in the morning, 2,000 you had withdrawn and you had spent at various shopping malls, and this is the spendings, and finally you are with this much of money. Then the person will say that, okay, Alexa, that's none of your business. I'll pay through cash. So by asking my neighbors, sir, your relation with your neighbors was not good, and today morning you received the divorce notice from your wife as well, because since there was a fighting from last few months. So they may not give the money to you, and outside it is raining. At this time, you won't get money from anywhere. So then he generally will get, as a human being, will get angry, right? So fine. So then he will say that, Alexa, so you're entering into my personal life too much. So likewise he will start shouting. Then the Alexa will say that, sir, your BP is rising, and it may lead to the stroke also, and you may fail. That means recently you got stent also. So if you are shouting like that, I had to call the ambulance. For that time, my battery is getting drained. I cannot call the ambulance also. So please don't do such activity. Don't get angry on me. Bye. See how That means how our data is stored into the cloud, and how other devices can access our data, how our data is publicly available, how much security for the data. So one device can tell complete information about us. That is what uh, that means the conclusion of the story. See, similarly, how people are trying to create what we can say, a common cloud for the patient's information as well. Suppose if I'm going to, previously if I go to one hospital, if I had done some tests, and if you are not comfortable with that particular doctor, if you go to other hospital, then again you have to go for the tests from the starting onwards. So now onwards, soon there may be a system which stores the information in a particular cloud. Suppose if you go to an hospital, the information will be stored into the cloud. Okay, these are the values, and these are the HbA1 values, or these are the BP values, or these are the mm, uh, other test values, angiogram value. That means angiogram test value, and so this is the CT scan results, and all this information will be available in public cloud. If you go to other doctor, you need not go with the tests again, and the information can be extracted from the cloud, and he will verify and he will give it. So this kind of applications will be useful for the um, uh, insurance agents as well. Suppose whenever they are going to give insurance agent, they will go through our medical history. Based on that one, they will give policy. So such kind of things can be implemented. So likewise, people are started working, and these are some healthcare AI startups that are identified to watch. Fitness is there, and Strava is there. Mental health, Mindstrong is there for identifying the mental health. Then nowadays, if you want to do the meditation, there is a wellness app is there. In Wellfulness app is there in Apple, and Sophia Genetics. Suppose if you want to order medicines, MedPlus is there, NetMeds is there. Suppose if you want to get this decision from about your disease, there are some apps are already available. Medical Imparters, Lean TAS. So these are some startups. What could be the risk? Suppose if I'm using the monitor for these many hours, if my screen time is this much, then what kind of diseases I may get? Otherwise, at present, my sugar levels are this much, my BP values are this much, or my heart rate is this much. What kind of risks are there in future? So this kind of analysis can be done with these initial startups. Anyways, coming to the medical informatics, there are many subdomains available. I had taken it from Wikipedia. That is imaging informatics, clinical informatics, nursing, consumer health informatics, public health, dental, clinical research informatics, bioinformatics, and pharmacy informatics. So out of that, I had taken medical imaging in this thing, so to explain. So the importance of this, suppose if you are taking a kidney scan, so if you are taking a part of kidney, a stone is there or not, one can identify whether the functionality of the kidney is there or not, whether the pipe of the kidney is blocked or not. So fine, these kind of things can be told. So examples of medical imaging. So medical imaging coming from bottom to top. So various what we can say, various cancers can be detected, or classification of the images into uh, whether there is a damage in the particular portion or not can be identified. So starting from mammographic mass classification, segmentation of lesions in the brain, we can see that, and breast cancer is there or not from the mammographic images, leak detection in the airway, and diabetic retinopathy. That means whether the diabetes is affecting the eye retina or not, and prostate segmentation can be done, whether there is a enlargement in the prostate or not. So because of prostate enlargement, you may get less flow in the urination and all those things. nodule classification in your lungs, if there is a nodule cancer or not, whether it's a nodule or not. Also, doctors have to identify breast cancer. Metastasis detection can be done. Skin lesion classification, one can tell whether there is a dermatology. People can say that whether there is a damage in the skin or not, skin cancer is there or not, and bone suppression can be identified. So there are variety of applications needed for the people, and people are looking for various research articles on these kind of applications. So this is based on the survey that has been done in 2017. I had downloaded this paper, and based on that one, I had classified. So some statistics based on the survey article. So what are the techniques that they have used? So where blue indicate the number of papers published. Blue indicates that including all, that means total number of papers, especially on CNN, how many papers have been published. So 2012, 13, 14, there is no involvement of CNN. But from 15 onwards, CNN has played a major role. 15, 16, 17, CNN ruled, and that means it outperforms various other machine learning models. So fine, there is a restricted Boltzmann machine, RBM, and RNN is there, recurrent neural networks. And so these are some techniques has been used. Out of that, number of papers published for MRI scan, microscopy, a majority of the images is papers published for MRI. MRI is nothing but it is for that means medical resonance images. Is it medical or magnetic resonance? Fine. Similarly, for breast cancer, they will do the mammography. Mammography will be used for this breast cancer analysis. So in this work, I have taken the example of breast cancer data set. Someone has switched on mic.
Dr. Satyaranjan Jaina, please kindly mute.
So fine, the imaging chain. So here COVID-19 just data set, we can tell, one can tell so the most of the number of papers that have been published in 2020 and 21, so will be based on the COVID-19 just data set. So one can see whether COVID is positive or negative based on the images scanned, that is based on the X-ray images or CT data set. Fine. So same way, what we are going to do. Sir, tell me, sir, Syed sir. Do you want to say something? You are raising hand frequently, that's fine. Yeah, fine. So the same way, whatever we had done in the last time, whenever we had developed one RNN application, how it has been done in the same way. Syed sir, tell me. Syed sir?
Dr. Syed.
If you want to ask any question, then you can ask.
Yeah. I think by mistake.
Yes, sir.
By mistake, actually, the hand.
No issues, sir. No issues. See, fine. We can give this image and feed it to convolution process. Then we can apply ReLU, rectify linear unit, then max pooling, then provide it to the deep learning and classify whether it's a COVID positive or negative. So this kind of simple CNN architectures we had seen in the many COVID that is COVID classification based on COVID-19 classification based on just images. So fine, major advances that as of now, image classification is one of the things that has been done in this particular field. Then image segmentation including that what are the, suppose if you are giving the brain images, where are the cancer particles are there. Those kind of things can be identified. Then CAD analysis and computer content-based image retrieval. So, and image annotation. Suppose if any image is given, we can use proper annotation for that image. Suppose if any crime scene, so crime scene image is there. The Gen AI can nowadays Gen AI can explain how the crime has been happened also from starting to ending. It can that kind of thing. So coming to the major advances, we can early detection of the disease, which can be used to cure immediately, and computerized treatment will always give the proper results when compared to the human errors. I will show some human errors also in upcoming slides. So I don't want to take much time. So here I had told that I will take the data set as breast cancer data set. Breast cancer. So that thing, there are other types of cancers also there. Lung cancer will be there, and colon cancer. So in this case, what will happen in the sense, if you take thoracic CT scan, that means thoracic CT scan, which will generate generally 240 section images by the radiologists. But analyzing 240 images will obviously take some time, and there might be some human error in that while analyzing them. So then we have colon cancer. Colon cancer will be generally colonology, colonography they will do. So it will be related to the lungs only, that means lung part. So it will generate generally 400 to 700 images. So these are the two things that have been identified. So coming to the mammography for the breast cancer. See, some generally, if there is no dense in the breast, suppose if you are taking the breast and if there is no dense, then the cancer can be easily identified. That means one doctor can easily see that and he can recognize the cancer molecule from this particular left side image. And coming to the right side image, this is also mammogram. Just these images are called as mammograms, and by using mammography, they will extract these kind of images. So this image is also normal. That means dense breast. So in this case, even though there is a cancer component, cancer molecule, it is very difficult to identify by the doctor. In this case, we need a machine support to extract. Sorry, I think video is not good. Fine. Yeah, we need a machine support to identify whether there is a cancer molecule or not. Fine. So here the doctors will face a challenge. So generally mammogram is nothing but it's a X-ray of breast tissue used as screening tool, searching for cancer when there are no symptoms of anything being wrong. So the lumps in the mammogram will give the lumps in the mammogram. So fine, the left side if you see, the left scan shows a normal breast while the right one shows malignant classifications. That means left one is normal breast, but the right one is having some malignant. So that means the cancer will be the breast will be normal breast, or it is a benign cancer or malignant cancer. Benign is benign and malignant. That means the complexity of the cancer level. So see, similarly, suppose if you are taken lungs images, this is called as nodal. This red, what we can say, boundary, red bounding box of color red will be called as nodule. So this is a cancer component. Fine, one can easily identify. So here also one is there, we can identify. Here there are 3 cancer component molecules. Here one, but doctor may say that these are also cancer molecules. This is cancer molecule, and this is cancer molecule. Doctor may say this all these are cancer molecules. In this lung, if you see, there is only one cancer molecule, but doctor may say all the some of them. Here 1, 2, 3, 4, 5, 6 he may say. So the difficulty in identifying the nodules in the given lungs will is challenging for the doctors. But here we need it can be done by using it can be easily done by using the machines. So fine, this is the image I had taken from one I had redrawn, but I had not taken the same image. I had redrawn. So mammogram acquisition, digitizing, pre-processing, feature extraction that extracts the loss and features. Then they had given to the PSOWNN, particle swarm optimization with the neural networks, with wavelet neural networks. Sorry, particle swarm optimization wavelet neural networks have been introduced, and they specified whether the given image is having normal or abnormal, but they could not classify it as a benign or malignant in this paper. With feed-forward neural network, they got this much of accuracy, and that is around 76%. With wavelet neural networks, they got 84% accuracy. But this work is published in 2014. That means not to say not recent work. It has been published in 2014. You can see 2014 is a publication. So fine. But now the involvement of deep networks, the involvement of CNNs has outperformed this particular task. And recently the papers have been published with more than 90% accuracy. So fine. Another important statement, another important reason why computer-aided characterization is required. So whenever we are identifying the nodules in the lung, so then if you are, this image has been given to the four different doctors. This image you can see clearly. This image has been given to the 4 different doctors. Reader 1. So there are parameters that include lobulation, that is equivalent to 4 specified by reader 1. The malignancy, the complexity of that is 5. So highly suspicious, and the sphericity, that is the volume of that particular nodule is equal to 2. Reader 2 has mentioned it as lobulation is equivalent to 1, and it is marked in that image. Malignancy equal to 5, highly suspicious, sphericity is equivalent to 4. Reader 3, lobulation is equivalent to 2, malignancy equal to 5, so highly suspicious and sphericity equal to 5. And he is mentioning that it is a round shape sphericity. Then reader 4, lobulation is equivalent to 5, none malignancy equal to 5, and highly suspicious sphericity is equivalent to 2, and he's mentioned that it is a ovoid shape. See, if this image has been given into the 4 doctors, and if 4 doctors are giving 4 different parameter 4 different values for the parameters of lobulation, malignancy, highly suspicious level, and the sphericity, then what the patient can decide whether he has to go. So because of some parameter values, if he has to go for a surgery or kind of thing, then the patient will be in confusion whether I have to go for surgery or not. So hence we need computer-aided characterization in this case as well. So fine. The solution is deep learning, as I said, that all these things I have discussed with you people in the previous lectures. So what I will do is I'll directly go for the hands-on session. I'll explain this problem from basic starting thing onwards. So for this purpose, I will use ChatGPT as well, because the part of this session is Gen AI also. I will use ChatGPT, one of the generative AI for present trend. Am I right or not? Fine. Hands-on medical imaging. So folder is not required here. Is it visible? Table 1.
Yes.
So import numpy as np. Import pandas as pd. Import matplotlib.pyplot as plt. Then import TensorFlow STS and import CV2 as well. So these are the required packages for performing this hands-on. Fine. So all the packages got imported. See, step by step up, I'll explain with the the Jupyter got opened in the tab. Fine. Anyways, so this is the ChatGPT that we are using. It's a premium version. Fine. Let us assume that data set for breast classification into benign, malignant, and normal. So there are different types of, there are various sources for this particular data set. So mammograph is DDSM is one of the data set that they are providing. Breast cancer digital repository is there, and mammographic image analysis database is there. Curated breast imaging subset is there. InBreast is there. So these are the different sources. I include the data set of breast classification into my Jupyter notebook from the Kaggle. So there is a Kaggle source also in this. I'm including it directly from the Kaggle. So for this purpose, I'm using pip install Kaggle. I think I have not installed Kaggle in my system. You have to restart the kernel. Reload. So then here there are two import OS and import Kaggle. So Kaggle, I don't want to have that has to be copied. The JSON file I have to copy. I don't want to do all those things now. So I'll go for a dataset download directly from the Kaggle website. Yeah, here breast cancer dataset. I'm downloading. So breast cancer dataset, there are different people. One is Nancy A. Aswath. So this dataset will be Yeah. The CSV file. We need images. No. What happened? I had downloaded this dataset also. Yeah, fine. This is CBAS DDSM. So as I specified in the ChatGPT, the same thing. DDSM dataset. CBAS DDSM, sorry, curated breast imaging subset and of DDSM. So this is a breast cancer image dataset. It will be having images of JPEG. Not this dataset also. Yeah, ultrasound image, not this one. Data card summary 10.2. Fine. CSV files are not required for us. There are 3 classes: benign, malignant, and one simple dataset used to be there. Yeah, I think this one. Just 1 minute, I'll download the dataset quickly. Let me see whether I can download it or not. So fine, I think I can download this. Yeah, fine. Now we shall develop the code remaining part. So let us assume that. Shall I use ChatGPT so that it will be very easy to write the code? So in general, we have to explore the package called as OS. OS is nothing but it will be similar to the Linux commands on list directory, and all those things can be done with OS itself. How many files are there? How many directories are there inside? All these things. So there is at the same time, image data generator is another package that is very, very important here. So classify the benign, malignant, and normal images of 3 folders using CNN. So develop a code. Python code to so these are the packages that I already told. Let us assume that dataset is having trained, benign, malignant, and normal. Validation is having benign, malignant, and normal. Train directory is dataset train. Validation directory is equivalent validation and dataset validation. Okay. So I'm going to my Python. Yeah. So what is it? Yeah, validation and string closing. Fine. Now this is my train directory, and this is my validation directory. So this is fine. Now this image data generator, I told, right, one more class, there is a thing called as image data generator. It is available in the tensorflow.keras.preprocessing.image. There is an image data generator. Will be useful to rescale the images and divide it into train and test. All those things can be done by using this particular thing, image data. So train data gen, image data generator. Rescale, that means the images will be converted to 0 to 1. The pixel values will be converted to 0 to 1. From 0 to 255, that is scaling. Rotation range will be 40. And width shift range is 0.2. Height shift range, I didn't explore these things. Horizon flip is equivalent to true. That means we are going to generate the new augmentation also we are going to do. Fine. This image data generator is done. And similarly, I'm doing it for the validation data also. Yeah. You shall see by this time the data gets downloaded. Yeah. These mammograms. So this is one taken for some very few images are there. What we can do is first 4 can be classified into 333. 10 are there, right? 334. Benign, malignant, and normal we shall keep it. Okay. There is no validation set, assume that. All images, Control X. I have the complete data set. Maybe in my college system, I'll provide it once with Bane sir. So Python experiments, hands-on. Yeah. Hands-on medical imaging. Fine. New folder. Train, I will keep it. Train. In this benign, malignant, and normal. So these are the images. First 3 I'm keeping it benign. Just I want to explain the process of doing it. Don't bother whether accuracy is good and all those things. And these 4 are for normal. Yeah. The same I'm keeping in the validation as well. Clear. So this is my data set. Fine. The next thing is, yeah, train generator, train data generator from the directory, train directory. Target size equivalent to 150. That means the target image size will be 150 to 150. Batch size we need not mention. Class mode is categorical. Similarly for the same thing, test data. Yeah. So validation data gen and train data gen that flow from directory. What is the problem here? Okay, we have to keep all these things in the data set. New folder, data set. Yeah, fine. Yeah, found 10 images belonging to 3 classes. Found 10 images belonging to 3 classes. So correct, right? So that means we have train data and validation data, but I kept it as same images. Please don't bother about it. Don't bother about the content of the folders, because I could not get the data set in short time. Fine. Then I will explain this model. This model equal to sequential model. See here. My model equal to sequential model of first 32 filters. That means I'm using 32 filters of 3x3 filters. And for input shape, that is 150 by 150 by 3. The input shape of the images will be 150 by 150 by 3. And max pooling is done for 2 by 2. Then convolution will be done again 64 filters, 128 filters, 128 filters. Then we had done the flattening. Then dropout of 0.5. Dropout is not, if you don't want to do the dropout, then fine. Then dense of 512 hidden neurons, and dense of 3. 3 is nothing but benign, malignant, and normal. This is my model. Since sequential is not done, so I will include those packages as well. The packages are so import tensor from tensorflow.keras.models, import sequential, contour D, max pooling DT, flatten, dense, and dropout. Now model summary, model dot. See, now you can see the initial image size is 150 by 150. Since stride is equivalent to 1, 150 minus 3 plus 1, that is 148 by 148 after performing the convolution. Then this 148 by 148 image has been divided and has been downgrade, subsampled to, I cannot say subsampled to, I cannot say downgrade, subsampled to 74 by 74. Then further next convolution process, 74 minus 3 plus 1, 72 by 72. Then max pooling 36 by 36. So here 148 by 148 by 32 filters. Then 72 by 72 by 64 filters. Then 36 by 36 by 64. Then again convolution operation has been done. So the image has been reduced to 34 by 34 by 128 filters have been used here. Then after max pooling 17 by 17. Then come 3D 15 by 15 128 filters. Then max pooling 7 by 7. That means the given 150 by 150 image has been reduced to 7 by 7. So that is the beauty of the here that you have to understand. Finally, flattened layer will be 7 by 7 by 128. How much it is? You can take calcium, do it. 7 by 7 by 128, that is equivalent to 6272 features have been extracted. Okay, that has been given to 512. 6272 into 512, that is equivalent to 3211,264 plus 512, because bias values, that is 32,011, 32 lakhs 11,776. Next, 512 by 3, 1536 plus 3 bias values, 1539. So if you can understand these parameters properly, these hyperparameters properly, done. You need not learn any other thing. Everything will be taken care by our generative AI. Can I proceed like this? Can someone respond? Can I proceed like this? Yeah, fine. So this is what the sequential model. Then after doing it, so history, that means model fitting, train generator we had given. Steps per epoch is equivalent to 100. Epochs, number of epochs equal to 30. That means each epoch will be having 100 iterations. Then validation data, validation steps will be 50. So we shall see how it looks like. So this is my history. You must compile your model before training testing. Use model dot compile optimizer. Yeah. This model dot compile we have to do. Loss equivalent to categorical cross entropy. Optimizer equal to Adam optimizer. Adam optimizer is the mostly used one. Metrics equal to loss and accuracy if you want accuracy. You can put F1 score and all those things also. Those things. Yeah, fine. There are 30 epochs I'm using here. Because there are no proper steps. So I'll remove this part. The maximum accuracy that we got till now is how much it is 0.5. 0.5 is that is 50% of accuracy we got, because the data set is improper. So that's why it is 50%. Sorry, now the last it is 40% accuracy for data set, and the validation accuracy is 0.5. Loss is 1.1054. So we can plot the loss and all these things here. So this is loss versus accuracy. That means train loss and validation loss. How loss value had come down and how accuracy value got increased. Likewise. So I'll explain one more problem quickly based on this one. So I had done it already for you people, and that is that is cat classification, cat and dogs classification. So the same packages, whatever I had shown in the ChatGPT, the same packages I imported. So whenever I'm importing lengthy packages, I had kept at top, and down I had kept at that is short. Short in the sense OS, CV2, NP, that is NumPy, TensorFlow, Matplotlib for plotting, Keras Tensor, which is a sub-package of TensorFlow, and TensorFlow also has been imported. Optimizers, pre-processing, and image layers, and all those things I imported later. So you can see the data set including cat and dog images. I'll explain that. Yeah, these are the cat images, and these are the dogs images. One beautiful dog I'll show. 2276 dog.2276. Load image. What happened? Okay, data train dogs. Huh? Anyways, I'll show directly. Name IMG is not found. What happened? CNN classification only, right? Oh, sorry. Data train dogs and 22. Yeah, that particular image is not there, I think. 1 second. Data train dogs 2276. 2726. Sorry. 2726. Yes, a beautiful dog image. The images of the dog are varying. So some images are 450 bit, some images are 300 bit. So different images. You can see 2726. It is 374 height and 500 width. So we can do the rescaling of all the images. For the purpose, image.data generator, all the color images have been rescaled to 0 to 1. Normalization has been done. All the images are then further rescaled to 128 by 120. Here, as same code, data train, target size is equivalent to 128 by 128. Batch size is equivalent to 3. So this is done. We can give 128 by 128 by 3 also if you want. So there are two classes of images. One is dogs and second one is cats. Similarly, here also 128 by 128 by 3 because I want to use the color images directly for the classification purpose. Train dot data class indices. Cats index is 0 and dogs index is 0. So in the train data, so there are how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 20, 21, 21 minus 4, 17. So 21 plus 17, 38 cats are there. And 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 plus 21. 39 images dogs are there. So I can count the value counts also. Value counts is not working. Fine. Yeah. Train data dot value counts we shall see. No, this directory object is not having value counts. I'm sorry. Yeah. So there are 38 cats and 39 dogs are there. Then TensorFlow Keras sequential model. 16 filters are used. 3 by 3. Activation is equivalent to value. Input shape is equivalent to 128 by 128 by 3. Then TF dot that means max polling 2 by 2, 32, 3 by 3 ReLU function. Then max polling 2 by 2, flatten 256, and dense is 1. That means finally that it is a binary classification. Now, can anyone tell me total number of parameters required? Can anyone? For executing one image, total number of parameters required. Can anyone calculate it? That is the beauty. If you can calculate at this stage, you're perfect with the convolutions. So 128 by 3. So we are using 16 filters, 3 by 3. So it is 126 by 3. Then max pooling, it is 61 by 61 by sorry, here 16 filters. Sorry, 16 filters are used. Here it is 16 filters. This is after convolution and max pooling. Then 32 filters. 61 minus 3 plus 1. How much it is? 61 minus 3 plus 1. Can anyone guess? What is the value 61 minus 3 plus 1? 59. 59 by 30. Then max pooling. 15 by 2 is equivalent to how much? 29 by 32. Then flatten. So flatten is equivalent to 29 into 29 into 32. How much it is? Calculator. 29 into 29 into 32. 26,912 filter features. This is given into 256. That means a hidden layer of 256. 26,912 into 256. 68 lakhs 89,472 plus 256 because bias values. 68, 89, 984. Into 1 plus 1, that is 68, 84, 89, 985 is the last level. So these are the parameters. These many parameters will be, the sum of all these parameters will be used here. I can see. I'll print model.summary. You can see the same thing, whatever I had drawn. 128 by 128 by 3 is input. It is converted into 126 by 126 by 16. Further, it is, sorry, 63. My wrong, it is. It's 61 I had given. 63 by 63 by 16. 63 minus it is 61 by 61 by 32. Then it is 30 by 30 by 32. So then I had to calculate for 30 by 30 by 30 by 32. Where is my calculator? 30 by 30 by 32, which is equivalent to 28,800. Into 512. Sorry, 256. Plus 256. 73,056. Then 73,057. So these are the, yeah, you can see 28,800. The same thing has come. Then into 256 plus 256, that is 73,056. Sorry, finally it is 257 only. I'm sorry, 256 by 1, right? Yeah, 257. So totally these many parameters, that is including 73,78,401 parameters my model is having, random parameters. Generally, this will be black box. It is very difficult to understand these values. If you can understand these values, you can do miracles and you can come up with your own model. That is the beauty here. Fine. Then model that fit train data steps for epoch is equivalent to 3. Epoch is equivalent to 30. What is the problem here? Could not broadcast input array shape 3 by 28 by 28 by 3. So I had given wrongly here. Yeah, fine. This is also, I think I need not mention the third dimension here. Yeah. Then I had done it for 30 epochs. 30 epochs is very less. That's why accuracy, though the accuracy is 1.00, that means 100% accuracy is there. If you want, I can model fit. Yeah. Now I can plot the model fit values if you want. Take from here. I think I have not taken history yet. Yeah, fine. This values I'm taking. Accuracy. I'm printing the accuracy versus loss. Model underscore fit. Previously it is history. Yeah. Validation class. Your train we shall give. You can see the accuracy and loss. So loss is from it is 0 almost, and these are the accuracy values. Initially it is 0.4. There is a high deviation in the accuracy, so that means the parameters have not been set properly. So this accuracy values will help us to visualize the gradient descent also. So the highest accuracy that we got is 1. So I had taken some images randomly and I had given it to predict. You can see this has been classified as cat. This also has been classified as cat. This is classified as cat. This cat has been classified as dog. This is misclassification. This is cat. This is cat. Sorry, this cat has been. This is dog only. Sorry, this is dog only. This is classified as cat, but it is actually dog. This is classified as cat. Actually, it is dog. This is dog. This is dog. This is cat. Because of confusion. Because of so out of these many images, some cats have been classified as dogs, and some cats have been classified as. Sorry, some dogs have been classified as cats. This is the way of building a deep neural network with CNN. So fine. Likewise, we can do many things. I'll explain one more PPT quickly. Yeah. Generally, whenever we are taking the natural intelligence, the difference between the how natural intelligence will be working in the sense, human thought will be there. we'll add some emotion, and it will be consciousness. Coming to the AI, machine learning, deep learning, and computational power. So where here both in both the ways, what humans will see and machine will see in the sense pattern recognition, adaptive learning, and decision making is the more three important things that will get overlap in between natural intelligence and human intelligence. Coming to the natural intelligence, we'll learn by expertise, that means by experience, and emotional awareness will be there. That means we know what kind of emotions that we have to express at that particular stage. Empathy. So whenever someone is in trouble, we should not go and laugh in front of him. So that is empathy. How we show. So creativity. That means we have our natural intelligence is having the creative nature and problem solving strategies. We self-awareness, so we can identify what the based on the present scenario self-awareness can be done. Consciousness will be always conscious. Generalization ability, so that means we can generate that means we can generalize the things. Humans can interpret situations, emotions, and all those things based on that one. They can generalize the things. Ethical reasoning, morality, so we know what to do, what not to do. So making choices based on social norms and moral values. So intuition and gut feelings, unlike machines, humans can sometimes reach conclusions based on gut feelings. So pattern recognition can be done, and the ability to communicate and express. We can communicate with others and express the things properly. So coming to the artificial intelligence, what should be included inside that? Learning and adaptation. So AI can learn from data and improve over time without being explicitly programmed for each task. So once if you train, so for the particular data, it will automatically learn the things. AI excels at identifying patterns in large data sets, which aids in predictive analytics. So suppose if 300 images are there, from the 300 images, if there is a cancer molecules are there, humans will take a lot of time, but AI can quickly, that's a speed and efficiency. Coming to the scalability, so AI can expand for larger data sets as well. But the problem is lack of emotion and bias reduction. So there is no emotion, there is no bias. Okay, he is my person, I have to do something favor to him. Such kind of things will not be there with AI. Reliable data, reliable results can be provided. These kind of things, some points I have been kept. So if I explain all these things, it will take a lot of time. So I will conclude this session with one beautiful video. Then you will understand where we are. Is it visible?
Yes, yes.
One video, recent video. Audio is not there, right? Yeah, I'll share it with audio. Is it audible?
ముచ్చటే తెలుగులో మాట్లాడడం చాలా బాగుంది. ఏమైనా
Yes.
చెప్పాలనుకుంటున్నారా?
Yes.
పర్లేదు పండు నేనే
Sir, it is humming.
One second. Wait, I'll share it with audio. I'll reshare the screen with the audio. Okay. 1 second. I think I can share only audio based, tab based. Share. Yeah, this video.
In this universe, in this life, things open up only where you pay intense attention. Where there is no attention,
మనం తెలుగులో మాట్లాడుకుందాం అనుకున్నాం కదా పండు.
Whether the audio is not.
ముచ్చటే తెలుగులో మాట్లాడడం చాలా
Yes,
బాగుంది. ఏమైనా చెప్పాలనుకుంటున్నావా?
నేను చెప్పేది ఏముంటది పండు, నువ్వు చెప్తే నేను విందాం అనుకో. అనుకుంటున్నా కానీ
Is it audible?
పర్లేదు. పండు నేనేమన్నా కథ చెప్తాను
sir.
వినాలా?
వద్దొద్దు, కథలొద్దు, కానీ నేనే పెద్ద కథలు చెప్పేవాడి, నాకు కథలొద్దు. స్కై డైవింగ్ ఎందుకు చేస్తారు జనాలు, అది చెప్పు చాలు.
స్కై డైవింగ్ అదొక విపరీతమైన అనుభవం. జనం ఎక్కడో ఆకాశంలో నుండి దూకితే అదొక రకంగా భయంతో కూడిన సంతోషం, సాహసంతో పాటు స్వేచ్ఛను అనుభవిస్తారు. అంతేకాకుండా ఎగురుతున్నప్పుడు కనిపించే ప్రకృతి దృశ్యం అద్భుతంగా ఉంటుంది.
అబ్బా, బాగా చెప్పావు పండు, థ్యాంక్స్.
ఎంతైనా నువ్వు చెప్పినట్లు కథలు చెప్పడం కంటే వినడం కొంచెం తక్కువేనేమో. ఇప్పుడు నిరుద్యోగానికి అలవాటు పడుతున్నావా?
నిరుద్యోగం ఏంటి బ్రదరు?
అది బాగుండింది. కొత్త దానికంటే అలవాటు పడ్డ పనిలో మనసు కలవడం సులువు. ఎప్పుడూ పనిలో పూర్తి ఆనందం కలిగించడమే ముఖ్యము. పనిలో ఆరిజైన ఆసక్తి, సంతృప్తి ఉంటే చాలు.
చాలా ఎక్కువ మాట్లాడుతున్నావు పండు నువ్వు.
ధన్యవాదాలు. నీతో ఇలా మాట్లాడటం నాకే చాలా ఇష్టంగా ఉంది. మరేం ఇంకేమైనా
వద్దొద్దు,
చెప్పాలనుకుంటున్నావా?
చాలు, ఇది చాలు చాలు, థ్యాంక్స్, బాయ్.
సరే పండు.
See, now we are at this stage. That means we can speak with the devices in the same way how we interacting with others. So with this, I'm concluding this session. Hope this was useful. Any queries? Any queries?
Participants, any queries? Please ask.
I could not see the chat box. Yes, sir. Obviously, we can generate the synthetic data with Generative. With Generative, at present, I am generating the ragas also. If I want any raga of a particular music, I'm generating the raga with the Generative. Generative can do magics. Any other queries? So I think Pardhasaradhi sir is waiting for the next session.
I-
Yes, sir.
I think there are no questions, sir.
So how was the session? One or two oral feedbacks? Yes, sir. I will share the course with you, sir. Mani, sir.
Yes, so somebody can give the feedbacks. Abdul,
Khadir, sir.
Abdul Khadir.
Kadir sir. Okay, one or two oral feedbacks, fine. Anyways, sir, Bunny sir.
Yeah.
Thank you.
Okay, sir. Thank you very much, sir. On a short notice, also you have accepted our invitation or whatever responsibility we have given on an emergency basis that you have accepted. Thank you very much. And again, your style of presentation that everybody likes. So last time many have given the feedbacks. They like your style of presentations, how exactly you show the coding and explain each and every step that everybody likes. Thank you very much for the detailed information about today's information about medical imaging. Thank you very much.
Thank you so much, sir.
And I think Pardhasaradhi joined. Let me see.
Padu sir has joined. I had seen him.
Yeah. Good afternoon, sir. Pardhu sir. Pardha sir.
Good afternoon, Bunny sir.
Good afternoon, sir.
Okay, sir. I'm leaving, sir. Thank you. Thank you so much.
Okay, Vishnu sir. Thank you.
Hello, sir.
You stop the recording and start.
Yeah, I will stop the recording and I'll start again for the next session. Okay. Thank you.